Okay, this is my first supplemental lecture referring to network math. Three of the things that fall under that category and what I'm going to discuss in this is calculation of the network address, calculation of the broadcast address, and subnetting. So that's what I plan to get through today. So when we're doing the broadcast and network address, we start with information such as shown here, labeled example 1. You are given an IP address and a subnet mask for this device on the network. So then we ask the question, okay, what is this host network address, or what network is this host on? So we get that information by applying the subnet mask to the IP address and going through and doing the calculation. Now, one of the first shortcuts we can do is asking a question, do we really need to convert all the octets to binary? Do that bitwise and then convert it back to decimal dotted notation to get the answer. And the answer is no. And, I would normally ask my students why. And the answer is because if we have a subnet mask portion that is all ones, for example, the 255, the second 255, we know that if we AND anything with 1, that we're going to get the same thing back. So in this example, the first two octets are just going to move down as is, 172.16. If we look at the last octet, which is in the subnet mask, which is 0, anything bitwise AND with a 0 is going to be a 0. So even if we expanded this out to decimal, did the bitwise and then we're going to get all zeros, and then we convert that back and we get a decimal 0. So, that leads us to which octet do we need to worry with. And of course, the only one that we didn't discuss is the third octet, where we have a 240 in the subnet mask. So what I'm going to do, just to prove our point, is let's look at the second octet. Students are usually pretty comfortable with the fact that if you AND anything with 0, you're going to get 0. So we won't worry about the fourth octet. But so we have a 16 in the IP address. This is the binary representation of 16. In the subnet mask, we have 255, which is every bit set to 1. Then what we would do is we would do a bitwise and again, you can either apply the truth table or just remember that if you AND anything with a 1, you get with what you started with. So 0 and 1 is going to be 0, a 1 and a 1 is going to be a 1, for example. So what happens is after we do this bitwise AND, we get this binary value. If we then convert that binary value back to base 10, it's going to be 16, and that's exactly what we started with. So anytime you AND anything with a 0 in the subnet mask, it's going to come down as 0. When you AND anything with a 255, it's going to come down with the exact same value. It's going to stay the way it is. So now that we've gone through that, let's actually worry or look at the one we care about, which is the third octet. So in the third octet, in the IP address, we had 85. What's shown here is the binary representation of 85. In the subnet mask, we had 240. Here's the binary representation of 240. Again, it's very important to remember that a subnet mask is a whole bunch of 1s followed by a whole bunch of 0s. So before this 240, we had 16 1s for the 255 portion, and then we have 4 bits into the third octet. The third octet ends with a series of 0s, and of course the first octet was all 0s. So, we can look at that and say, that seems to be a valid representation of the subnet mask. So now if we do the bitwise AND, this is what we're going to get as the answer. Just to specifically point out the purpose of the subnet mask is to divide the network portion from the host portion. So that's just showing you the division point there where the ones in the subnet mask turn into zeros. So that's the bitwise AND. So what's left is to convert that back to decimal, and that is the representation of 80. So that means, how do we get the network address? Well, from the result of the bitwise AND. So when we do that, we converted that third octet to 80. That gives us the 172.16.80.0 is the network address. Another answer or another fact that's important to remember is you can just set all the host bits to 0 because they're getting ANDed with a series of zeros, and the answer is going to be 0. So whichever way makes the most sense to you is fine. Now we ask the question, how do we get the broadcast address? And the answer is by setting all the host bits to 1. So if we look at this kind of in decimal and binary, so in the network portion, we have 172.16 dot, and the first half of that third octet is the network portion, so we have 0101. And now what we have to do is set all the remaining bits, that is specifically the host bits, to 1. So that is our broadcast address. And then when we convert the binary to decimal, we're going to get 172.16.95.255. This is a helpful table. I think I mentioned this previously, but since a subnet mask is a bunch of ones followed by a bunch of zeros, I didn't specifically put all zeros on here, which of course would be 0. But if that first bit is set, then the subnet mask is going to be 128. If we have a octet where the first 2 bits are 1 and the remaining 6 are zeros, then for subnet mask, the value of that byte or octet is going to be 192, all the way down to every single bit being set. And of course, that's when we get 255. Okay, so here's example 2. It is also calculating the network address and broadcast address. So we're given a host address and a subnet mask. Here we can see that the first 3 octets have all 1s because they're 255, 255, 255. So something's going on in the third octet because we have 224. So what happens is to first talk about the network address. The 192.168.0 is just going to come down because we're ANDing that with 255s. So in that third octet, we have an IP address that has 92, and we have a subnet mask of 224. So that is going to be the division point as far as the network portion and the host portion of the address. If we do a bitwise AND of this, we're going to get 0, 1, 0, 0, 0, 0. So all those host bits are set to 0. That means that the network address that for the network that this machine is on is 192.168.0.64. So that's the network address. The next question, of course, is what is the host broadcast address? Apologize, I labeled that wrong. So we look at the last octet again, which was 010 in the network portion of it. And then what we've done is we've set the remaining 5 bits to be a 1. If we convert that to decimal, we get 95. So the broadcast address for this network is 192.168.0.95. Okay, the third example relates to subnetting, specifically when we're trying to create equal size subnets. So we're given an initial IP address and net mask in slash notation. So 192.168.0.128 slash 25. And we want to subnet it so that we have 5 equal-sized subnets. So when we're doing fixed-size subnets, the question we need to ask is how many bits do we need to borrow to make our subnet? And we do that via a formula that we need to remember. And typically I would ask the students in lecture, what is that formula? And of course the answer is we need to solve the equation 2 raised to the n power is greater than or equal to the number of subnets we need, and we need to solve that for the smallest value of n that makes that true. And again, I would ask my students, what is that? And the answer is 3. 2 to the third is 8. That's the smallest value of n that makes that equation true. If we looked at 2 to the second, try to borrow 2 bits, 2 squared is 4. 4 is not greater than or equal to 5. So bottom line is we need to borrow 3 bits out of the host portion to make this work. So our original network portion is 192.168.0 dot, and that 1, that third octet, is going to be shown in binary. So that's actually the high bit, the 128 out of the network number. Then what we need to do is we need to borrow 3 bits, which I'm showing here in red, and then that will now leave us with 5 host bits for each of the networks. Now, the way we get the subnets is by going through all the possible combinations of the 3 subnet bits. So we start at 0, and that would be our subnet 0. This would be our subnet 1, our subnet 2, our subnet 3, our subnet 4. Of course, all we're doing is just going through this, from 0 to 7 in binary. Next one would be 5, next one 6, and our last subnet would have all 3 of those bits set to 1 and would be referred to as subnet 7 because 111 in binary is 7. So looking at this a little further, our new subnet, we're going to have a network address of 128. That's the original value that we started with, but notice that the subnet mask that we started with was a /25, and now we had to make that a /28 because of the 3 bits we borrowed. So 128 is subnet 0, so the subnet bits are set to 0, 0, 0, and then our remaining bits are 0 because all host bits set to 0 is the network address. The broadcast address is 143. The reason it is 143 is because we borrowed, we have subnet bits set to 0, 0, 0, and all the remaining host bits set to 1. So that's 143. Subnet 1 is if we set the subnet to 001 and we want the network address, so we set everything to all zeros, all the host bits. That's how we get 144. The broadcast address is 195. Subnet bits are still 001, but all the host bits are set to 1. The other thing that I want to mention is if you're asked for usable host, the first usable host on subnet 0 would be 100000001, and then the last one would be 100011110. So all the IP addresses between the network address and broadcast address would be usable host. If we move on to subnet 2, the network address is .160 because that is the binary representation of what we have for subnet 0 with all the host bits set to 0. The broadcast is 175. There's the setting of those bits. Subnet 3, we set the subnet bits to 0, 1, 1 because that's binary for 3, and that is the network and broadcast address for subnet 3. If we move on to subnet 4, the network address is .192 and the broadcast address is 270 from the binary values that we have over at the far right. Subnet 5 is going to be 280 for the network address, or I'm sorry, 208, and then the broadcast address is going to be 223. So, and that's subnet 6. It's going to be 224 and 239. And the last subnet, subnet 7, is going to be 240. So we have all the subnet bits set to 1, all the host bits set to 0, and then the broadcast is going to be 255. The 1 from the original network, the 3 ones from our subnet 7, and then all host bits set to 1, which would give us the last 4 ones. And of course, a byte with all the values set to 1 is 255. So if you go back and look at those, you might note that the difference between each network address is 16. And it's always 16. So is there any significance to that fact? Well, if we think about that last octet in this example, we had the first high order bit was set to 1 because that was part of the network address. Then we had our 3 subnet bits, and then we had our 4 host bits. So if we look at the binary weights for each of these positions, you know, we have the 1s, we have the 2s, we have the 4s, we have the 8s, and then we have the 16s. So the first weight that is not part of our host portion is 16. And is there any significance to that? Well, yes, it is. Cisco refers to this as the, quote, magic number in their curriculum. So if you go through and look at that and look at the weight value of the position right after you go from host bits into subnet, that should be the difference between each of your network addresses. So that's 3 examples with what is typically referred to as network math. I will do more examples and more presentations like this in the future to help you get comfortable with this.